our webinar on emerging trends in enterprise telecom. My name is Dennis, and I have Tom Daly here with me, and we'll introduce ourselves in a moment. But a couple of housekeeping items before we get going. Just as a reminder, if you're not able to stay for the entire thing, or you want to share this with any of your colleagues or anything like that, you will get the recording of this webinar sent to you via email within 24 hours. And also in that email, you'll also have a form that's like a survey on just how good the webinar is. So please provide some feedback, fill out the survey. It'll help us put together better content in the future. And throughout, we absolutely want to make time to answer questions. So please do utilize the Q&A feature in Zoom to submit questions, and we'll pause at a couple of points to try and answer questions throughout. So let's get going and start off by telling you a little bit about who we are. So to introduce myself briefly, my name is Dennis Thungachin. I'm the CEO and co-founder of Lightyear, which I co-founded in 2019. So I've been doing this for nearly 5 years now. And prior to this, I did investment banking at Goldman Sachs, and I was investor in public and private markets at a hedge fund called Point State Capital. That was a $10 billion hedge fund where I spent a lot of time investing in telecommunications, which sort of led to the opportunity that is Lightyear. Tom, do you want to introduce yourself briefly?
Yeah, happy to do so, Dennis. Thanks for the opportunity to speak today. Folks, my name is Tom Daly. I'm the Chief Executive Officer at Big Network. I was formerly the co-founder and Chief Technology Officer at Dyn DNS, as well as the Chief Architect of the Dynect Managed DNS Network. And then spent a few years over at a content delivery network called Fastly, building out their global infrastructure. We built out over 100 terabits per second of connected data center connectivity and peering at a number of locations around the world. And most recently, a couple of years back, came over to Big Network to start working out at the edge of the internet, the true edge of the internet, and partnered up with the folks over at Lightyear to help folks strategically source and procure telecom services.
Awesome. Thank you, Tom. And we have an action-packed agenda for you today, where we're going to spend the vast majority of the time talking about a few emerging trends in enterprise telecom that we'll touch on in depth piece by piece, and also provide both my vantage point and Tom's vantage point onto these, and provide some interesting data points as well. And then we'll spend a tiny bit of time telling you about what we're working on at both Lightyear and Big Network, but ideally spend most of the time just talking about trends and answering some questions. So please do ask questions throughout. So to get going, let's talk about some trends around a shift in enterprise focus from network expansion to network cost optimization. So at Lightyear, we provide software that helps enterprises buy and manage their networks. And we see a lot of very specific activity about what enterprises are doing at specific times, what they're buying, why they're buying it, and any specific trends there. So in 2021, as the economy in particular was a bit hotter, enterprises were buying network, in particular focused on facilities expansion and company growth, with a lot of procurement focused on COVID-related operational changes lingering from 2020. And unsurprisingly, coinciding with changes in interest rates and inflation beginning later in 2022, enterprise procurement requests began to shift heavily toward consolidation and cost optimization. And this powered the bulk of requests we saw on the Lightyear platform in 2023. And this is not uncommon in the sense that typically when periods of recession occur, you see corporate leaders more willing to embrace changes that might otherwise be painful to incur or incur some human capital costs, so long as they'll drive costs down. And we saw this play out on the networking side in a few different ways. So first, CIOs were willing to undertake complex network transformation projects so long as they cut costs. For example, shifting from on-prem voice to cloud-based voice, MPLS to SD-WAN, moving from public cloud to private cloud. these are the types of projects that incur very real human capital, very high switching costs, and are very involved and can sometimes be painful, and are avoided until you absolutely have to incur them. So we saw a huge uptick in these types of projects. Second, we saw aggressive pushes for enterprise cost benchmarking of their existing services and a willingness to move outside of the enterprise's typical vendor suite to work with new vendors to introduce more competition in RFPs that they were running. And finally, we saw significant investments in better organizational tooling to identify unnecessary network services or unused capacity. At Lightyear, we sell a network inventory manager tool that does this, and we saw a significant uptick in demand there with a heavy focus on identifying what's in your network and rationalizing or disconnecting services to cut spend. Tom, at Big Network, I'm curious, have you seen more of a focus on cost optimization centric network transformation changes or anything of the sort?
Absolutely. I think our story parallels with a lot of the themes that you just said, especially from a network architecture and network topology design standpoint. If you go back to 21 and 22, literally it was grow network at any cost to keep the newly remote user online, no matter what. And that may have been through, deploying mobile connectivity to your employee base's homes. It could have been to expanding cloud services for, teleconferencing services like Zoom and Teams, where it was literally just open the floodgate, no matter what we need to do, keep the infrastructure up and available because we need that capacity for our users. Because really in the pandemic era, the topology of the internet changed in a lot of ways. We had an internet that would be used at home in the morning and the evening, and you had a business side of the network that was used during the day, and that completely inverted on itself. That grow at all costs mentality in 21 and 22, as you said, ended. And now you had a lot of additional capacity and assets out there that definitely needed to be optimized and right sized as we return to the office. And sort of the change in topology started to flatten out. So we're absolutely seeing the same types of concerns from our customers at Big Network. They're looking to simplify, rationalize, and like everything in IT, do more with less, do more with less.
Yes, do more with less is certainly something that I'm sure all of the attendees of this webinar are familiar with, or probably dealing with right at this very moment. And by the way, as a reminder to everyone here, please do use the Q&A function to submit questions throughout. We'll make sure we save some time at the end to answer any questions. But yeah, everything, Tom, you noted aligns very much with what we've seen at Lightyear. So on a completely different note, one of the biggest and most exciting telecom stories of the past several years has been the growth and introduction of Starlink, which is a low Earth orbit-based satellite provider owned by SpaceX, which currently has something like 3 million subscribers and has been growing pretty rapidly. And historically, satellite connectivity has existed for a while, but satellites haven't been useful as an enterprise-grade primary or backup connectivity option because of very high latency and crappy bandwidth offerings, as there are just physical constraints at hand. The satellites were very, very far above the Earth, and sending bits from here to there is quite taxing. And also the antenna technology that they're using was not great. And there also weren't a ton of satellites out there. So you had those things up. Satellite offerings were both expensive and just didn't perform that well. Starlink has really changed the game. And since 2022, they've introduced satellites that orbit much lower than the traditional satellite tech in more dense clusters of satellites with much improved antenna technology. And although the latency is still typically worse than what you'd see with fiber, you can get performance out of a Starlink connection that is comparable to a terrestrial grade broadband or fiber connection with completely global reach. And that's a huge disruptor. Now in rural or underserved areas where enterprises need a primary or backup connectivity option and a solid ISP isn't available, or maybe there's only one option, we're seeing enterprises more often opt for Starlink. And as Starlink's network improves, enterprises now may have a satellite-based connectivity option in the toolkit for their WAN. Typically, we see enterprises buying some form of a managed Starlink offering from an MSP that offers this, as Starlink's offering is quite bare bones and does require some management on the part of the enterprise for setup, billing, and things of that nature. And it does come with a few operational complexities of its own, but it's great to have a new tool in the toolkit for lots of portions of the world that are undercovered. And curious, Tom, with all your experience in enterprise WAN and WAN build out and just observing all the enterprises, what do you think about Starlink as a passable connectivity option? And are you seeing that within the WAN footprints of enterprises you're dealing with today?
Yeah, absolutely. I'm seeing that enterprises are looking at Starlink very, very closely, and they're trying to figure out if it's a viable option. And a bunch of the trade-offs that you mentioned, Dennis, are the questions that we're seeing. We're seeing the customer base across Big Network asking themselves. A couple different things are popping up. What does the latency profile really look like? And what I can say is that in the continental United States, as an early adopter of Starlink myself, as well as seeing a bunch of rollouts into customer environments, it really looks like a cable modem, a DOCSIS plant type service from a latency, jitter, and throughput standpoint. Early Starlink services back in 2022, easily pulling down 400 megabit per second, 150 meg up. You're not going to use this as your primary connection for your 1,000-person enterprise office, but as a backup that is survivable through weather, through power outages, through all the things that the traditional network in the ground or on the poles need to get through from environmental concerns, Starlink becomes an amazing option. It doesn't have the same susceptibility as, say, like LTE, mobile LTE and mobile 5G services do to disruption, especially as you think about how important antenna alignment is in the 5G world. And then just the coverage is phenomenal, right? As long as you can get a clear tree canopy for the Starlink deployment, and that dish has a full field of view of the sky up above it, you really have connectivity that can parallel what you're getting through, say, terrestrial DSL, or as I said, a terrestrial cable modem. The challenge becomes integrating that into the enterprise WAN. If you're thinking about how to deploy Starlink, say, against maybe your large tier one carrier services, it looks a lot different. There's a lot of feature and capability that's not available on the Starlink network that you're picking up, say, from an AT&T or Verizon, enterprise services. And it comes around things like integration, visibility, and observability of the solution. It's very, very hard to, if not impossible, to get static IPv4 addresses on the Starlink platform. Not impossible, but pretty hard. And when you don't have that option, you're often stuck behind carrier grade NAT. And carrier grade NAT for many networking subsystems out there, whether it be traditional IPsec based VPNs or various SD-WAN platforms that require these static IP addresses, is just kind of a non-option. So the enterprise is looking at this thing, they see it as a viable option, but they're still trying to figure out how to tie it into their enterprise WAN because they just haven't seen this series of use cases before.
Yeah, that's exactly right. And in terms of what we're seeing via Lightyear today, a lot of the requests, particularly from, call it, Fortune 500 enterprise, tend to be exploratory in nature today, rather than a sort of facilities-wide rollout, as they sort of understand the puts and takes of some of these concerns. So I think Starlink has only existed in and been commercially viable for the past 2 years. So we'll see how this trend plays out.
It's a real trend, though, and it's a great opportunity to continue to democratize the last mile of the network. There's a similar opportunity inside the 5G play, but I think we're still all looking at 5G saying, hey, is this really going to be a viable technology for us? Everyone's staring at it. There's a lot of technological promise here. Now it's how do we operationalize and integrate it, into the design patterns and architectures that we're used to.
Yeah, the three things playing out there. So 5G wireless and LTE-based wireless have gotten much better. Satellite has gotten much better with Starlink, and ideally that prompts more competition in satellite. And even just terrestrial broadband and fiber have gotten better, and there's more competition. So the over trend is more options for the enterprise WAN, which is, I think, good for all of the attendees here.
Now, Dennis, before you move on, we did have a question come in from one of our viewers asking, does satellite open up security concerns?
Yep. Yeah, I think actually you'd be well suited to take that one.
Yeah, so I don't my limited experience is I don't think so, right? You know, Starlink is managing the network. I don't know specifically about their encryption that may exist over the satellite links and whether or not you can really snoop into the microwaves. But think of it like this. You would deploy this outside your firewall. You would deploy this on the WAN side of your enterprise network, which is generally, in today's world, it's generally internet access out there at that point, right? We've seen so much of it move from private point to points or frame or MPLS to the internet. So I think as long as you're deploying something like Starlink in the same fashion as deploying dedicated internet access, cable DSL, whatever that underlying medium might be, the security posture is no different than that of an internet circuit coming into your business.
Awesome. So switching gears here, one of the most well understood stories of the past couple of decades is the shift away of compute and storage from on-premise infrastructure to the cloud, whether that be public or private. And eventually, as public clouds kept getting better in terms of ease of use, cost, flexibility, ease of maintenance, improved application ecosystems, public clouds kept growing and consuming market share, and talk began of public cloud infrastructure making the need for private cloud or premise-based infrastructure obsolete to some degree. However, in recent times, it seems like perhaps we have reached what looks like peak public cloud penetration. Perhaps not, but in recent years, enterprises really began to observe that the public cloud is very expensive, for one. At small scale, public cloud setup is cheap, easy, costs are low, but the cost curves scale very non-linearly, especially for non-commodity workflows operating at enterprise scale. And that made operating in the public cloud many times much more expensive than operating in a private cloud, or in some cases even a premise-based cloud infrastructure. There's a lot of nuance to this, but it is generally the case that this is true. These cloud infrastructure providers are making lots of money, and that does involve markup of infrastructure that they're selling to you. And they're making the most money from people operating at the largest scale generally. And there's actually a really good blog post by Andreessen Horowitz that's worth a read about what Dropbox observed at scale when operating its business out of the public cloud and why they ended up making a transition back. And second, it's worth noting that public clouds are really good for commodity compute and storage use cases, but don't offer the flexibility of private infrastructure for customized or highly specific workflows. And this is come to the forefront very recently today for enterprises building out AI infrastructure. Also, compliance and security posture is easier to maintain and stay on top of in a private cloud environment generally. So in recent times, as budgets have come into focus and there's been a bigger push toward more unique and compute intensive workflows like those you'd be utilizing for AI, we've seen a resurgence of interest in private cloud and hybrid cloud infrastructure relative to years past. Long run, I think workloads will live where they operate most efficiently from a cost and performance perspective, and you'll see much more of a hybrid approach. And Tom, I know you firsthand dealt with some of this transition, and also are there any specific trends or enablers that you've observed around this trend?
Yeah, absolutely. I think there's two key things for enterprise architects to be thinking about on their journey from the traditional enterprise data center to public cloud, and then perhaps back to private or on-premise cloud. And that's the concepts of data locality, data gravity. Where is your compute versus where is your data? And then the second concept is around, just the evolution of tooling that has happened over the past 10 years or so of public cloud. So let's talk about data locality and data gravity for a second. You know, in this AI-driven world that we're marching towards, to train these AI models, you need to feed a massive amount of data to them to be able to create an inferencing set to deploy out to the network. And that training process needs massive amounts of parallel compute, but it also needs to be able to absorb ingest a massive amount of data to perform its training. And this is, as Dennis said, this is creating a challenge where, AI training is not a commodity workload. It's not necessarily suited best for public cloud. It is ideal for very distinct, purpose-built parallel computing facilities. But if your data set, if your training data is sitting in one of the large public cloud providers, and you're looking at something like 8 cents a gig or 12 cents a gig for egress to get it back out to your private cloud, you're going to pay a lot of money to move that data set out to that private cloud for training purposes. So enterprise architects are really wrestling with a connectivity quandary of, do I pay the premium for keeping my data next to this massive parallel compute that I need to train the data set? Or do I shift that cost to some sort of private network, transport, interconnect medium to be able to get that data over to my private training cloud to build that AI model? That's going beyond and saying, well, do I really want the data to reside in the public cloud at all? Or would I rather have sovereignty over my data in my own private cloud and then bring that back into public cloud providers when it makes sense? So we're literally seeing trends where enterprise architects are suggesting, hey, we're going to build something like a 400 gigabit Ethernet link into public cloud providers so that way I can get at my data. And perhaps when I'm done training a model, I might just throw the copy away and start all over, or vice versa, because of the economics of cloud ingress and egress. So that's one thing that we're seeing enterprise architects wrestle with. The other side of it is private cloud is actually possible now in the first place because of the massive tooling evolution that's happened over the past 10 years. I really think that public cloud has had its day because of the tooling that came with it. Imagine if you could have an SRE or a DevOps team the size of Amazon or Google or the Azure team. I mean, that's what they're really providing to you, is highly functional specialists that know how to run infrastructure for you at massive scale and expose that infrastructure as a series of APIs, so that way you have infrastructure as a service. That tooling is massively powerful. And what we've seen is a number of companies like Equinix releasing an open source tool called Tinkerbell, and Canonical, the makers of Ubuntu, delivering a tool called Metal as a Service, or the Ansible group delivering really powerful open source tool sets that give you those API driven workflows to private infrastructure. And for maybe those folks that don't want to take on the overhead of an open source tool, a number of new platforms coming across, Platina and Verge and Netris, that are taking these modern cloud architectures and putting a developer friendly API on the front of them. So that way the overhead of actually rolling private cloud in the enterprise becomes absorbable and manageable, and have a fundamentally viable life cycle with it that we didn't have in the data center world of 20 years ago.
Yeah, it's an interesting note that you bring up there regarding the enablers. Like Equinix is one of the best examples where they've made private cloud management similar or more similar to public cloud management, which is a huge enabler. And an inverse trend is playing out right now, which could maybe even change this specific view a few years in the future, where there is a huge wave of startups that are observing some of the difficulties in doing specific things in the public cloud, and also a large TAM for example, in AI-oriented compute or compute around very specific workflows or architectures, where there are multiple startups trying to vie to become the public cloud for AI, become the public edge cloud, become the public cloud for X architecture. And I'm not sure how all of that plays out. It'll be interesting to see. But definitely, I believe things will probably look different than they do today as this continues to play out.
I agree with your prediction. I think we will start to see a resurgence of platform as a service type tools that continue to get closer and closer to the core infrastructure layer as time goes on.
Yep. Awesome. And it's worth noting here, here's a chart. It's actually like slightly out of date, but the data is actually a little bit astonishing here. This is a survey from IDC to a group of large group of enterprise CIOs, talking about workloads currently in the public cloud. And when I note like peak public cloud, they noted that something like 71% of respondents were noting that they're going to move partial or all of their workflows in a public cloud into some form of a private cloud or non-cloud infrastructure within 2 years, whereas only 13% were noting running fully in public cloud. So this trend has been sort of like playing out for a couple of years. AI is a very specific and timely thing here, but worth noting that was actually a larger response than I would have expected. All right, Tom, you want to take this one?
Yeah, I'm happy to talk about the evolution of the traditional enterprise WAN into the world of SD-WAN. SD-WAN looked like it was going to be the Swiss Army knife that was promised to fix all things for many different enterprises. But we're starting to find out that we missed a couple things with SD-WAN, and now it's time for something new. And we're starting to talk about what next-gen WANs might look like. So let me take you through some of the high points in this table. It's all about what is old is new again, and what is new becomes old again. We sort of see the cycle, through this. So if we just look at, really the locations that, these technologies have had to serve, the traditional WAN had this like very fixed, known border around it, from corporate HQ to the branch and out to the data center. And as we got into the era of SD-WAN, now we're starting to see just the number of points that network administrators and network architects need to be aware of just massively expanding. No longer all your business apps sitting in the data center. It's across, 200 some odd SaaS providers, 3 or 4 different cloud providers. And now as you get into the needs of the next gen WAN, as we just talked about, we're moving workloads back to the private data center as well, except we now call it private cloud instead of data center. One of the biggest points of elasticity in these models is just the level of control that's given to the enterprise. If you go back all the way to the traditional enterprise WAN, I mean, this was something that had to be stitched together by enterprise administrators from day one. They were off buying point-to-point circuits, T1 lines, frame relay, lease lines, and then stitching that together with massive amounts of CapEx, routers, firewalls, switches to create that enterprise WAN. The big advantage to carrier WAN in the form of multi-protocol label switching or MPLS was that you took all that workload out of the enterprise and turned that into something that the carrier would do for you. So you had a solution that became carrier designed, sourced, and operated, which was great because you generally had 1 or 2 throats to choke, but it came at a massive level of inflexibility because this is the enterprise WAN administrator. You can't run that yourself. So that's really where SD-WAN came in. The first versions of SD-WAN came in, was really to provide like a common shim between what was going on between the carrier's responsibility for the network and what the enterprise wanted to have for control. And so what we saw in SD-WAN, it was really always this level or this layer on top of MPLS where I use these SD-WAN appliances to gain some control back from the MPLS network. And when something goes wrong with the MPLS network, I'm already, chances are, buying internet access at the branch, at the HQ, and I can start to use that internet access as a backup. Yes, we've returned some control and flexibility back to the enterprise, but we've actually introduced a bunch of complexity in the sense of now it's a co-managed solution that has to exist between the enterprise and the carrier. Now, at the same time, the workload concentration didn't change that much. I mean, you still had HQ and branch, SaaS and cloud, but we didn't have the massively remote workforce that we have today. And so this is where in the next gen WAN, we have to consider a few different things. First of all, we have to understand that where our workload is coming from is, highly distributed. It's coming from the branch, it's coming from HQ. It's coming from the remote user at home, the remote user on the road. So, just from a security model standpoint, building out that hard perimeter firewall around your enterprise is no longer going to work. And at the same time, where the work is going to has massively splayed out. It's 200 different SaaS applications. It's 3 or 4 different cloud providers. It's perhaps your own private cloud in a distributed network of locations. So no longer do you sort of have this clean, hub and spoke model. You just have a full mesh model that needs to be adopted by the next gen WAN. So let me take you through some of the cases for next gen WAN, and that'll be on the next slide, Dennis, if you wouldn't mind moving us ahead. And it's really, these key points. The perimeters of the WAN have just shifted. There's many more devices, endpoints, and access types to deal with. The applications are all over the place now. And legacy WAN technologies, lead to inefficiencies of the network. It leads to the need for cost optimization. But from a user perspective, it's latency. We're seeing a point now where your traditional MPLS or SD-WAN architectures are actually introducing a huge amount of latency in for the user experience because they're all built on hub and spoke models and not distributed meshes. In those models, there's a lack of observability. There's a ton of outdated security models that are built around traditional perimeter security, and that is leading to a bunch of unnecessary expense. So enterprises are in a place now where they have to truly reevaluate the WANs, and they're looking for a few key, guiding North Stars that align that WAN with their key needs. So number one is an open architecture that allows for on-ramping of traffic from a variety of user locations and off-ramping that traffic to public, private, and data center clouds. And then really getting rid of these specialized carrier networks in favor of internet access as the underlying transport. These WANs now need to not only carry traditional secured enterprise traffic on something that looks like SD-WAN technology, but it cannot sacrifice latency or performance for cloud workloads, which is requiring a lot more emphasis on technologies like local breakout and failover across a variety of internet access circuits, either at the branch or HQ. And then we said, IT is always tasked with doing more with less. So, network reliability through automation is high on everyone's list because we have to always be online, but we can't tie up humans to manage and maintain the network. So how do we use automation to enhance that? And then finally, security has to be built in from day one, but that security has to come with low latency. So that way the human can work as fast as, the human can work efficiently and quickly through their day-to-day tasks without the network getting in their way.
Awesome. And just to sort of like showcase some of these points with some data, here are some visuals around survey data from a number of CIOs from a couple different sources. If you look at the chart to the left, you can see here, this is just what you term SD-WAN adoptions, not necessarily next-gen WAN adoption. And you can see that even from 2018 to 2022, the amount of enterprises that are in their installed or rollout phase of sort of a Gen 1 SD-WAN solution is in the realm of like, call it 80 to 90%. So we're definitely past that first phase of deployment of sort of what you term SD-WAN 1.0, and you're now getting new WAN solutions oriented around some of the issues that have come about regarding the 1.0 of SD-WAN that Tom very specifically touched on. And you can see that playing out sort of to the right where most critical area of improvement for the 2023 networking budget, in particular, this survey was oriented around WAN solutions, particularly overlay WAN solutions. And the number one is network security, which sort of really has to be tied in now with an overlay WAN solution, whereas previously that wasn't a huge consideration. And on the bottom, you can see global connectivity in an SD-WAN managed service is now very important, and people want their overlay WAN provider to have a robust middle mile network. And in particular, that's like a huge area of demand. And that ties very directly into the sort of changing perimeter of the WAN and connectivity options available that Tom touched on. And I would pause here for more discussion, but just for the sake of time, because we got about 8 minutes left. And I also see that we don't have more questions, that we will dive right into just talking a little bit about what we're both working on at Lightyear and Big Network, because both of our companies and our offerings really tie very well into the exact trends that we just discussed. So I'll talk about how you can drive network optimization with automation and data via Lightyear. So we founded Lightyear initially because business telecom doesn't operate with the customer in mind. Your ISPs don't make things easy for you, unfortunately. Any workflow that you deal with around telecom, whether it be quoting a service, managing an implementation, tracking renewals, or placing a ticket on a service, tends to require a lot of manual offline workflows and lots of follow-up. Oftentimes, enterprises are making decisions around what to purchase, what vendor to use, things of that nature without data. And there's very limited transparency into things like vendor serviceability, what's a great price, how do vendors perform, and the like. And enterprises operating at any scale face difficulties keeping track of their service details, contract info, renewal details, and much more, often using spreadsheets or nothing at all at times. And you add all of this up, and that tends to mean inefficiency, which costs enterprise time and money, unfortunately. And that's why we created Lightyear. So Lightyear is a software product that we call the Telecom operating system. And Lightyear software digitizes and automates the entire life cycle for all of your telecom services. And it's built around continuous and systematic cost optimization rather than one-time cost optimization. So there are a few couple components of this. In particular, our procurement suite allows you to digitally create telecom RFPs and conduct exhaustive vendor searches with optimized pricing, and it's backed by the best data set in business telecom. Lightyear also has a network inventory manager that acts as a digital system of record for your network inventory, eliminating the need for spreadsheets and automating things like renewal handling and ticketing. And we can actually onboard your existing network inventory to this digital system of record. And throughout all of this, we provide white glove support around implementations, network engineering, renewals, service changes, and much more. And why is this worth your time? Enterprises who spend time using Lightyear are saving 70% or more of the time that they'd be spending on telecom procurement and vendor management, and are reducing their telecom budgets by 20% or more, and are set up for continuous long-term optimization because they're leveraging the most fulsome carrier network and data set in the industry. And really quickly worth noting, there are two primary components of the Lightyear platform. The first is our procurement suite, which automates the procurement process for new telecom services from RFP through to install. And it allows you to digitally create RFPs that'll conduct exhaustive vendor searches backed by the best data set in the industry. And it'll also automate project management for each component of your install process to make this easy for you. And we also have a team that'll help you with this entire process as well, powered by data. Post-install, we have a network inventory manager that is that centralized system of record for your network that digitally tracks over 30 unique data points on all of your services. And it automates a ton of service workflows, such as reshopping prior to a renewal, MACD ticketing, and much more. And it's worth noting, our procurement software is free to use. And if you procure services via Lightyear, you get the network inventory manager for free for those services. And if you'd like to leverage our network inventory manager for your existing network, there's a small fee involved, and that's scoped based on the quantity of services in your network. Hand it over to Tom to close out.
Yeah, so at Big Network, we're thinking about the next gen WAN and how that is, a departure from traditional hub and spoke networking topologies that were traditionally used on the WAN. So Dennis, if you want to flip a slide, we have dreamed up this open architecture for next gen WAN, where at an access layer level, you can really use any ISP and any connection, work around common network problems like NAT and CGNAT and a lack of static IP addresses. We've introduced some capabilities around a mobile virtualization layer. So that way you can use technologies like virtual SIM card and electronic SIM cards to provision connectivity on mobile networks. That way you'll never have to roll a truck to swap cards out in your modems if you take advantage of mobile connectivity for primary or backup purposes. An access virtualization layer that sits on top of our software stack that provides a low latency point-to-point tunneling mesh. And this is a huge departure from the traditional point-to-point tunnel or hub and spoke architectures or middle mile architectures that are out there. This really eliminates latency in the network depending upon your workload, whether you're going across the enterprise network in a traditional SD-WAN sense, or maybe you're doing something like local breakout to reach a cloud provider so that way you're using the most efficient pathways through the network. And where that gets us to is a place of being able to deliver services like unbreakable internet to the branch or static IP addresses anywhere. There's a number of applications that are out there today that are just simply incompatible with some of the newer, network access technologies like Starlink that we talked about because of a lack of static IPs being available. And that way enterprises can really get back to doing what's important to them, which is running their services and applications, whether it be security, cloud, SaaS, voice over IP, collab applications like Zoom, whatever it might be. So as you look at the Big Network platform, we're offering a open architecture for next gen WAN that enables you to on and off ramp traffic in all the locations that I mentioned earlier in the webinar and deliver highly robust unbreakable internet access. So Dennis, if you flip to the next screen, we'll talk about unbreakable internet access real quick, which is that we're enabling customers to use multiple ISPs at the branch, at the HQ, including wireless, mobile, and satellite, without incurring expensive major network changes or bringing BGP routing capabilities down to the premise. You can deploy Big Network cloud managed CPE to gain insight into your network around availability and reliability. Use our vSIM mobile connectivity solution so that way you never have to roll a truck for a SIM card or to debug ISP problems. Get that insight so that way you can reduce the need to send techs out and dispatch tickets. And then, in partnering with Lightyear, now we're able to truly develop end-to-end visibility so that way we can help orchestrate capacity upgrades, supplier changes, and to manage the overall telecom lifecycle. There's a number of key customers, Dennis, if you want to move ahead a slide, that are running on top of Big Network today, that are delivering things like unbreakable internet access, voice and video communications, remote access VPN, and private surveillance clouds built on top of Big Network as a platform, and happy to share success stories with anyone that might be interested down the road. Dennis, I think we're back to you because we're running low on time, sir.
Awesome. Thank you so much, everyone, for attending. And as noted, you'll get a recording of this sent to you with also any information requisite to get in touch with myself or Tom or anyone on the Lightyear Big Network team. Thank you so much for attending.